Hi, this is John Avina, and thanks for coming today. Today's going to be a different webinar than what we're usually used to. Usually it's just me talking and showing you slides. I guess the last one, what we did was we talked about tab with Chris Christian. This one is different, and this is something that I ran across that I found absolutely amazing. What we're going to look at here is an interval data or interval data in general and analyzing it, but actually an application that's really cool, that works really well for actually for people doing energy audits, but also for M&V people. And the reason I thought it was so compelling is it is dirt cheap. It's like a $20 per meter deal, which is to me nothing. The person who's going to be doing most of the talking is Dave Krinkel, and I'll tell you about him in a minute. One of the reasons I have a problem, not a problem, but I keep telling him he needs to increase the price. $20 is crazy. I keep telling him it should make it 40 bucks, which still is crazy cheap. And you'll see why, I guess, in a few minutes. I apologize about my voice. I'm at a Tony Robbins event, and they make us scream a lot and jump up and down and all this stuff. And this is what happens to your voice when you do such a thing. This webinar is, I'm basically going to introduce Dave, and then I'm going back to the Tony Robbins event, and Dave's going to take it from there. So let me tell you a little bit about Dave. I think most or all of you know what metrics is. We're not selling metrics here, but metrics, I think most of you are users, or at least that's how you found out about this webinar. Either you use metrics or you know someone who does. Dave was from SRC Systems, and he was my boss about 18, 19, 20 years ago at SRC Systems. He's the one that taught me metrics, and SRC is the company that wrote metrics. Well, Dave later went to, or SRC got bought by Silicon Energy. We were all going to make a fortune in the great stock boom, and then instead the company started crashing, and none of us got rich like we thought. And Dave, and Silicon Energy got bought by Itron, where Dave went to work. He'll tell you a little more about himself and what he does, but I just wanted to give you a little bit of an introduction of what you're going to see and why this is important to you. I think you're going to actually recognize it really quickly. This is amazing. So I'm going to turn it over to Dave, and Dave's going to give a little bit of his own bio because he knows more about himself than I do, and then he'll go right into it. Thanks, everyone, and enjoy this webinar.
Thank you, John, and have a good seminar.
Thank you very much.
Okay, hopefully everybody can see a screen. I'm going to keep the introduction very, very short. But actually, John pretty much gave you all the relevant details, and I'm just going to say it's probably a bit of a misnomer for him to have described me as his boss. I learned as much from him as vice versa, I'm sure. So I started Energy AI about 8 years ago, left Itron. It was actually originally an idea I was interested in within Itron, but it really wasn't their thing. So I started Energy AI to do this. And it came about through work that John and I have done for years, where we would sell these very expensive enterprise energy management systems to large energy users, companies like IBM and Safeway and the Defense Department and cities and large organizations, campuses, etc. And there would be a lot of hardware and software for them to centralize their energy data, and not just their bills, but their interval data. And these things were hundreds of thousands and sometimes millions of dollars between hardware and software. And what we would always do is we would do a training session at the beginning whenever we got all the plumbing connected and data started flowing. And the first thing we would always do at these training sessions is we'd tell the whoever the customer was, let's pick one of your facilities at random and let's look at the last 2 weeks of interval data, meter data, the 15-minute or whatever you have. And we would pull up the profile for that week or 2 weeks, and inevitably somebody in the class would go, that's not right. That building should not behave that way. It's not shutting down at night. Why is there so much load at 3 a.m. in the morning? What's happening on weekends? We're closed on weekends. Why is there still so much? Why is that bump happening on Sunday afternoons? And they, not us, but they would quickly zoom in and say, well, that's probably, you know, this piece of equipment or that piece of equipment, and I didn't know that was scheduled. And the bottom line is, at a glance, strictly from looking at interval data with virtually no analysis, people who knew their own facility could say, that's not right. And so Energy AI, as interval data has become more and more available, particularly from utilities, Energy AI is my attempt to make this type of very simple and preliminary analysis very, very easy to do, and not just something that would be cost effective and of value, not just for large energy users, but for anybody. I'm really going to talk about the methodology because I know this is a group of energy nerds like myself, and I mean that in a complimentary way. So it's going to really focus on methodology. And John also told me that a number of you are doing M&V. So one thing I'm going to stress at the beginning, what this is not, Energy AI, at least my type of analysis, is not a substitute for M&V, and I'll explain that in detail. Most of the current clients of Energy AI are folks like you who do provide in-depth auditing services, M&V, renewable PV integrators, energy wholesalers, people who are typically already working with their customers, and now they find that, hey, we can get interval data from our utility for free or low cost. What can we do with it? I'm going to jump right now into the methodology, what we look for, and again, how it differs perhaps from other more traditional analyses that you might be familiar with. What I'm showing you here is our standard. This is what John was referring to, the $20. This is what people get for $20. I get a report. This is based on a meter, and I'm actually going to skip. This is the front page. The first page of the report is, you know, essentially like the front page of a newspaper. It's supposed to show the highlights. I'm going to skip this so we kind of go to the detail, and we can come back to that if time permits. So the most important function of this analysis is, again, to show people how a facility operates from their meter's perspective. And this is going to be in the, I'm going to talk about, assuming we're looking at a utility meter, so it could be a whole building meter or part of a building. But when I use the term meter data, it can apply to any source of interval data. So whether it's a building automation system or data recorders or submeters or whatever, I'm basically using those, lumping those all into the term meter. So the first thing we do is we look for day of week patterns. We use a simple cluster analysis technique where we're trying to determine, are there days of the week for this facility which behave the same? A simple example, which this illustrates a bit, is commercial facility, Monday through Fridays, standard operating hours. Saturdays in this example is a little bit lower. Sundays pretty flat. So there's a wide variety of profiles we've seen. There are obviously 7-day-a-week operations where there's not much, you know, there is no difference from day to day. We have one client who specializes in large churches, and churches have a very distinctive profile where Sundays are obviously a busy day and the weekdays less so. So anyway, Energy AI identifies what days behave the same, and it tells you typically, in this example here, Mondays through Fridays, the load rises most steeply from 6 a.m. to 9 a.m. on 81% of weekdays. Now, this can be very interesting if we were looking perhaps at a retail facility that doesn't open until 10. This might be an opportunity. Maybe certain things are coming on too early. Drops most steeply from 5 to 7. Okay, that may be exactly what's expected. Often equipment is left running too long, so this could be a surprise to someone that, gee, why am I shutting down at midnight, for example? And it does the same thing for Saturdays and Sundays in this example. So here, Energy AI has said Mondays through Fridays are fairly consistent, Saturdays are unique, and Sundays are unique. And this is just the standard thing you probably all do, which is say, when does this facility most often peak? By the way, what we're looking at now, and I probably should have just started off, what do I mean by interval data? Well, the way we define it is hourly data or finer. So it's 24 readings a day, or every 15 minutes or 5 minutes or 30 minutes, whatever is available to you. And we are strictly looking at energy or demand data. So we're not doing any power quality analysis, for example. One thing that surprises a lot of people, this is probably one of the most surprising things, is what we call 24/7 load. This is load which is assumed to be driven by equipment which is almost always on. And you may be doing this already. It's nothing we invented. We typically ask for a full year of historic data. The analysis can be done with as little as 3 months, but we typically look for a full year. And after determining the days of the week, which are the busy days, which are the not so busy, the off days, we look at the off hours within those off days, and we make the assumption that whatever can be turned off during those off hours is off. And we look at how that hour or those hours would vary throughout the year. And from that, we make an estimate of this is what is always on. And in this example, it's about 54 kW is the load. That's about, on average, that's the lowest that this facility would drop to. And so that could be, most of it is probably legitimate, security, emergency lighting, whatever. But often this load is a lot higher than people expect. And we have found over the years, and you probably have found, this is often where the lowest hanging fruit is. It's not unusual to identify a lot of opportunities of things that can be better controlled or turned off through very low or no cost. So we make the assumption here that by hook or by crook, if you were to be able to reduce this by 10%, here's how much you would save. Energy AI, one of the goals, the key drivers for the design of our analysis is the only information that is needed for the analysis is the interval data. We're not asking for anything else about the facility, the construction, the type of installed equipment, operating hours, any other independent variables. And the reason we don't want any of that is simply because we want to make it as easy as possible for people to get this analysis. So when we say, gee, here's how much you can get from a 10% reduction, we can't be specific and say, oh, maybe it's lighting, maybe it's computers that could be turned off or whatever, because we know nothing about the facility other than its interval data. So this is just giving you a sense of a potential. If you could identify 10% reduction, here's how much you would save. And again, it takes someone who knows the facility, like you, who can really then identify if this is achievable and where it could be achieved. I mentioned at the beginning, this is not an M&V substitute. We do use a lot of M&V methodology, although with some changes. And here's the first example of that I'll give, which is weather impact, which is very simply, the standard weather regression that you're probably all familiar with. Certainly, if you're using metrics, you're familiar with it with bills. We're doing it with interval data. We do it on a daily basis. So we're looking at the energy use each day, how that correlates with daily average outdoor temperature. And we use the, just like metrics, the variable balance point methodology. We look at, where we get the best fit for heating and cooling, with different balance points. Where we start to vary is in several ways from a true M&V analysis. First is we do it by those day types. So for example, in this facility, we saw Mondays through Fridays are similar. So we do a correlation separately for Mondays and Fridays through Fridays. We lump those together, and we do another one for Saturdays and another one for Sundays in this example, this building. The other big difference is the quality of the fit. And I'm sure John and the Abraxas folks have told you, and you need a good, strong R-squared for an M&V analysis, and I guess that's codified in the protocols. But we use a much lower standard of fit, much closer, for example, R-squared closer to 0.5. And the reason for that is that, there's a lot of examples where a facility, it is driven by weather, but there's so much other stuff going on that adds noise, if you will, to their interval data, and it's particularly true of interval data, that we use a lower threshold where we say that a facility is affected by weather. So again, typically it's about 0.5 is what we would use. So what we will tell people is, again, like with the 24/7, we have said, gee, if you could lower that by 10%. Here we make some simple assumptions. If you could improve the overall efficiency by 10%, or if you could lower if the balance point, let's say the cooling balance point is too low or heating is too high, if you could do things to lower that or raise it, whether it's thermostat set points or envelope modifications, these are the type of savings you could see. Go into all this detail. I'm going to speed up here a little bit because I want to give you the full overview by 10:30, and we'll leave some time for questions. So what Energy AI does, and I'm going to actually flash way back up here. I should have explained this a little better. This is a very important graph up here. We make a model of the facility, of its typical patterns using, again, the interval data, the 15-minute data. And what we actually do is by day of week and by hour of day and by season, after adjusting for weather, we make what we call an expected use range. And that's this green band here. And we do that for every hour of the day throughout the year. And you can see how the green band's fairly nice and tight here on Mondays through Fridays. That means there's not a lot of variability or noise. The load, after adjusting for weather, etc., stays within a fairly narrow band. Saturday is a little wilder. There's more uncertainty here. Maybe, some Saturdays the facility is kept open, others it's not. And so we have this expected use range. And then we look for anomalies. An anomaly is what we call unusually high use. So it's when your actual use strays outside of that expected range. And we look for patterns in those anomalies. So in this example, 34% of the high use occurred during late night hours. So that may indicate stuff is getting left on regularly or whatever. And you can see sort of a macro view here. Some of that was happening in the summer. And we show a few examples, few examples here. This is just one example of a week where it happened several days, and it looks like something was left running later than usual, or it could be cooling equipment, which is they changed the schedule because it was a hot spell or something. Shows you sort of the highest cost days. So you can get a ballpark sense that, that cost me $100. Another significant reason why we say this is not M&V or not a substitute for M&V is many facilities, as you know, and particularly metric users will be very familiar with this, you have other independent variables either in addition to weather or instead of weather, which drive energy use. Maybe it's an industrial facility and there's production. So how many widgets they produce in a day or a week or a month will drive energy use. Or if it's a motel, hotel, it could be occupancy rates. Again, Energy AI, we don't know that information. We don't ask for that information. So we do a different type of analysis which attempts to capture the effect of independent variables that we don't have access to. And that's the seasonal load. And we use a technique from forecasting. It's essentially just a long-term moving average analysis where we look for, the way I like to call it, we look for long-term bumps. Now this example doesn't really have any, but or nothing too terribly significant, but sometimes you'll see, a good yellow bump there. And again, the assumption we make is that this is probably, because because it's something that increases and decreases over a long period of time, it probably is something that's, again, production or occupancy or whatever. So we're not going to label that as unusually high use. It's probably usual. It's something that's, that's expected, but we just still want to capture that and quantify it. So the way I describe this is usually those independent variables, which in a real analysis, like in metrics, metrics you can enter independent variables to see if they do correlate. We're doing just the opposite. We're saying, oh, we found a bump, and we're gonna, highlight that to you, and you can say, oh yeah, that's that's when we're our busy season. We recently did a hotel in the San Diego area, which is very seasonal and made a major portion of their use. Shutdowns. This is showing you, are there days, full days over the year that we analyzed, let's say, where the energy use was flat and very near the 24/7 level throughout the day. And we call those shutdown days. And it could be holidays, your customer's facility is closed, or maintenance periods, whatever. And we just simply list those. And if it is a holiday, we tell you what the holiday is. And what's interesting about this often is very revealing, because as in this example, we see Christmas, New Year's Day. Well, we have 2 different Christmases. We spanned a full year. But why isn't Memorial Day in here, or 4th of July, or Thanksgiving, or whatever? This often will highlight a controls issue where something is not set up to shut down on holiday. So I like to call this the case of the dog that didn't bark. So what's missing from here? And you'll see in a minute that you can track that down. So just a couple of, we call it the basics. We like to, as you've seen, we like to present everything as much as possible in terms of dollars, because that is more meaningful to, perhaps to your clients than kilowatt hours or kW or whatever. And of course, so where do we get the rates to, or the price to convert? Well, we do use for the US, Energy Information Agency has a public database, anybody can access it, which has retail prices to commercial, industrial, residential customers by state. So if it's a US analysis, we will use that as our database. We also offer clients, they can provide their own prices, or they can provide bills, data, and we'll derive the price from there. We do also offer an option to do a true rate model. So if it is somebody wants to, get down to time of use and demand, that is not in the $20 range, but that's an option that's available. I usually tell clients that it's not worth it to get really detailed on the pricing, because again, as you've seen, we make a lot of assumptions in the analysis. So this is not a substitute for an on-site audit or a detailed M&V analysis. So it's usually a bit overkill to do a true rate model, but some clients want it. I should say also, we're fully international. A good 15% of the reports we do are outside the US, and we've done them for about 20 odd countries now, and it will use local currency, etc. We also like to show the CO2 impact of saving. So if you save, or if you have excess use of so many kilowatt hours, here's the associated emissions from that. And we use a variety of sources depending on, in the US we use EPA data from eGrid. In Europe we use other sources, and elsewhere outside the US. Now what I've shown you is about half of the report. The other half is what we call the load calendar, which is very simple, and I just will show you in briefly. It's basically just month by month. Over, let's say, we looked at the most recent year for a facility. This will just summarize the whole year. And we used to offer this as an option because, it's just 12 months of, this graph over and over again. But what people told us was, well, you know what? We can see so much more in this. There are things which you missed, which your analysis didn't catch, and we can see them very readily here in this representation. You know, again, the black line is the actual use hour by hour. The green is the expected use range, and if it's red, that's when you went over. So anyway, this again gets back to sort of the original idea, which is that people can look at this type of information often and see things that somebody who knows the facility that we would miss. So I think that takes us almost exactly to 10:30 here. That's an overview of what we do. Again, none of this, or very little of this, was invented by us. It's just trying to package it in a way to make it convenient and affordable to even the smallest users. So a lot of our clients are very small facilities, small businesses. Most of our clients are not the end user, but folks like you who are, you know, they're energy expert. Because where this has the most value is if someone's sitting down with an end user and going over this and saying, okay, here's what we're seeing and here's how this translates, you know, to what we know about your facility, the installed equipment, and so forth. Of course, this assumes you have access to interval data. And as I mentioned at the beginning, that's becoming easier and easier. On our website, which is energyai.com, under the frequently asked questions, people often ask, where can I get this data, either for myself or for a client? And we maintain a list of interval data sources that we know about, mostly utilities. So you can look through this list, and if you're not familiar with how to get the interval data, comes in a wide variety of formats, CSVs, Excels, XMLs. We can handle them all. But anyway, it's becoming widely available. If you're in California, all the utilities in California, major utilities in California, make it available for free. If you're familiar with the green button, that's a wonderful capability. We accept green button data. So, Tyler, I will turn it back to you.
I appreciate it. Let's see here. Just double checking. I don't see any questions. So either we did a really great job or our connection's bad. I don't know. No, nobody's sleeping. Nobody's sleeping yet. So yeah, I guess first and foremost, thank you everybody for showing up. We really appreciate it. And thanks to Dave for making time. And I hope you guys got a lot of benefit out of this, as you do with most of our webinars. Thank you everybody for showing up, and we will see you guys next month.